Welcome to CO451 Networking. This is week 1 and this is the first packet tracer exercise on network representation. I'm just going to take you through the first exercise that Cisco provide in Packet Tracer, which is their network simulation tool, in order to help embed some of the learning from the slides and the presentation you've just hopefully watched. So it's good if you haven't done that, watch the presentation first, because that gives you the core knowledge you need for the practical. And this is the practical exercise developed in Packet Tracer, which is their network simulation tool. There is a link in the module area to access Packet Tracer from the Cisco website. You do have to sign in and sign up, but you don't have to pay anything. It's all free. You simply sign up, register with them, and then you'll be able to download Packet Tracer onto your own machines for you to use at home. All the files for the network Packet Tracer files are within the networking folders. So each week there's the presentation, and you'll find a copy of the slides as a PDF, and you'll also find a Packet Tracer file plus the documentation that comes with it. However, although I've separated the documentation for each of the Packet Tracers, so there's a PDF that goes as well, the file itself actually contains, the Packet Tracer file itself contains networking exercise documentation built into it. So you don't actually need the separate PDF that I provided. That's just because I provide it because some people do like to print it out and have a hard copy next to them while they're doing the exercise. But effectively, you can have the network notes there by you. They are in the actual network tracer, Packet Tracer file as well. So we'll see that in a second. So we'll just switch over to Packet Tracer. So here we are in Packet Tracer. I've just opened up the first this week's networking Packet Tracer file, which is 1.5.7 network representation file, and it's just opened up in Packet Tracer here. And when you open up Packet Tracer, you get a couple of windows. The first window comes up, this user profile window here. Now you don't need to do anything with that at all. You just need to cancel it and close. So that's for other sort of purposes really, but just use cancel and it will disappear for good. The other main window that comes up is the actual Packet Tracer exercise itself. So these are the instructions for the Packet Tracer. You can minimize these. You could even click on the close, but it will just minimize it. So it won't actually remove it even if you close it. It will still stay minimized on your desktop. And this goes with the file. So it's just the instructions for what you need to do for the activity. So what I normally would do is just simply maximize that window first so that I can read through the instructions. Now, with these exercises, they are supposed to embed your learning from the presentation. So it's really important that you read through them carefully, and you also step through each of the instructions and steps that they are showing you carefully as well. Make sure you do everything in order as it wants you to. And again, there's quite a lot to be learned from each of these little exercises, so they can't sort of be skipped through or rushed. You have to kind of just spend a little bit of time with them. I'm going to do this one now with you just to kind of show you how it works. So Packet Tracer network representation, the objectives are always normally at the top. So the network model in this activity incorporates many of the technologies that you will master in your CCNA studies. So CCNA is the Cisco Certified Network Associate. This is all the materials we use within the networking module. We're following Cisco Certified Network Associate because it is an industry standard qualification and certification, and these materials are really the gold standard in terms of materials about learning about networks. So you are learning towards the CCNA studies. Whether you choose to continue with those studies and take the examinations external to university, that's up to you, but you are at least studying for a sort of professional qualification in this area, or at least materials relating to professional qualification. So it represents a simplified version of how a small to medium-sized business network might look. Feel free to explore the network on your own. When you are ready, proceed through the following steps and answer the questions. So they're giving us a little network to play with and to explore and to answer some questions on. So note, it is not important that you understand everything you see and do in this activity. Feel free to explore the network on your own. If you wish to proceed more systematically, follow the steps below, answer the questions to the best of your ability. So I'm going to follow the steps that they outline, and but they're quite right. You should play around with the network, maybe have a little explore for yourself. Becoming familiar with network devices is just a question of understanding configuration and having a go, really. And the whole point of having the packet tracer available to you is that it lends itself to being very open to you actually having a go and practicing and playing around with network builds and so on. You don't have to buy any expensive equipment or have any network labs available to you. You can practice a lot of the skills and knowledge about using networking within this simulated environment. So it's very good. It's an excellent tool. It's been developed over many years, and it is the again sort of gold standard in terms of network simulation towards a certification of a gold standard. So there are other network simulators out there, but they normally cost quite a bit to sort of run, and even if they say they're free, you still have to download and buy the images for the actual devices and so on. So at least with the Cisco Packet Tracer, you kind of get everything in the box absolutely for free, and it can be used straight away to start to build networks that run. So like I say, there are others out there, but this is really the best for learning about networking. So what are the instructions then? So step 1, identify some common components of a network as represented in the packet tracer. So the icon toolbar at the bottom left-hand corner has various categories of networking components. You should see categories that correspond to intermediary devices and end devices and media. And the connections category with the lightning bolt icon represents the networking media supported by Packet Tracer. There is also an end devices category and 2 categories specific to the Packet Tracer, custom-made devices and multi-user connection. So the first part is list the intermediary device categories that you're seeing. So just trying to get you a bit familiar with what's in this Packet Tracer tool and how it works. So minimize the instructions a bit and have a look around. So this is Packet Tracer. You're in the logical view. There are 2 views in Packet Tracer, logical and physical. And physical aims to replicate setting up networks between distances. So you can go for like a home city all the way down to a network closet and sort of back again. So if you want to think about how networks might be located around a city or around a town or around a building, then the physical view aims to try to simulate that in some way. Mainly though, you stay in the logical view. So the logical view shows you the network topology from the point of view of what's connected to what. It doesn't show you physically where they are in the world. So in this representation, for example, we have a home office, which assumes is like a home office in somebody's house. We have a branch office, and we have a sort of central office. So we have a building. We have sort of 2 buildings, sort of 2 business buildings and a home building, and we have the kind of the internet simulated in between. So you know, this is as broad as a simulation can kind of get, and these could span geographical regions, which we could simulate with a physical view as well. But logical view is really where we mainly stay. If you're zoomed in or out too much, there are little magnifying glass symbols up here. It just allows us to zoom in and out on our network, and you can use the scroller bars at the sides to move around the area a little bit if you want to see more or less of an area. So there's a little bit of zooming in and out that you can do. So what they're asking us to explore first of all is down here in the bottom left-hand corner. These are all the individual devices that we can add and create within our network. So if I hover over them, it tells me in the middle there what they are. So these are network devices. And under network devices, I have routers, I have switches, I have hubs, I have wireless devices, I have some specialist security devices, I have some cloud devices, and so on. So I have various different network intermediary type devices here. So these are all intermediary devices that we might use. So routers, switches, hubs. Hubs, by the way, are older style sort of legacy products now, really. Very rarely to use hubs in a network nowadays. Mainly going to be switches and routers, of course. So these two are going to be the main type of networking device you're going to use. And of those, if I click on routers, it shows you various different models of Cisco router. So the nice thing is it all simulates Cisco equipment, and these are all their sort of models of router that they do. But this one here, the 1941 router, is definitely the sort of workhorse for packet tracer exercises and the CCNA. So we tend to learn everything about 1941 router. Under switches, we'll mainly be concentrating on the 2960 switch here. Again, another workhorse of the networking world, and one that the exercises tend to be focused around, and the materials and so on. We can do everything with a 2960 switch and a 1941 router, to be honest. So those two are sort of key components in any build. The only other thing that we might get onto, and I don't think you do so much in this module and in early sort of networking stages, is the 3560. These are multi-layer switches, so these have these little, there are actually some on this diagram, which is why I'm kind of pointing out. They have this kind of little sun type icon. I call it a sun icon. It's got like a circle in the middle and lots of little lines, arrows coming out from it. So that's like that represents a multi-layer switch. The thing about multi-layer switch is it kind of combines some of the functionality of a router with the functionality of a switch. So it kind of does a little bit of both. It's a powerful device, and it's quite expensive, but they tend to sometimes turn up on diagrams. So that's a multi-layer switch, and the 3560 is probably, again, one of those devices that you use a lot in if you need a multi-layer switch. So 2960, 3560, and the 1941 router. In terms of wireless devices and so on, probably won't use too much within that initially, but there is things that simulate like a home router, just to give you that kind of wireless at home device. If we move along the top, away from the network devices, the intermediate devices, we have the end devices, which are things like PC host, laptop, the server, network printer, IP phone. They exist within here. Mainly PCs and laptops and servers are what we're going to be using as end devices. Just to give you the full tour, if I move along here, we have components. This is more for, they do a little different type of module, different type of certification in sort of more electronic type stuff. So there's components for those, and they use Packet Tracer to teach that as well, but you don't need to really worry about those. Connections, which is the one they mentioned in the instructions. This is important because this provides our connections, our cabling between devices. So again, it's a simulation, so it doesn't represent every single cable you could possibly buy. It just represents cables in a sort of broad type. So for example, this straight black line here represents a copper straight through cable. So that's kind of any kind of Ethernet cable, really. And the one next to it is a copper crossover. That's a same thing, Ethernet cable, but just wired in a slightly different way. And then we have some fiber cable, telephone wires, coax, and these serial cables here. So this red zigzag is a serial cable. This icon is essentially the same, except this would plug it in. It has two different ends. It has a clock end and a non-clocked end, and you can choose which end you want to plug in first by clicking on the appropriate icons, either the clock end or the non-clocked end. We have some octal cable, IoT custom cable, USB cable, and so on. This one, the zigzag at the end, is for automatically choosing the right connection. I never recommend it. I prefer you to know what type of cable you want to use broadly when you connect up your devices, so probably won't refer to that one. Oh, this one here, the blue one, is a console cable. You need that to actually connect up a laptop to configure your devices. So in the real world, if you ever wander into a networking lab or a server room or something and find switches and routers, you'll find that one thing you'll notice is they don't have any monitors and they don't have any keyboards attached to them. So it's the only way to connect to them to do the configuration is via a special cable called a console cable, and you actually connect that cable into the back of a device, and then you connect it usually via USB nowadays into your laptop and use a special little bit of software called a terminal software. Putty is a good example of that. You may use that in other modules, but Putty, Putty software is freely available online to download. Putty is a kind of a terminal tool that you can use to access your devices via this USB cable, console cable, which you'll plug into a special console socket on the back of these devices, the routers, switches, multi-switches, whatever, in order to actually set them up from your device. Or you might remote access to them over the network. Of course, that can also be done later on. But initially, when you get them out of the box, you'll probably just plug into them where you are with your laptop. So various different categories. Like I say, the main categories, we've gone through them all really. So routers, switches, hubs, wireless devices, they're your intermediary devices. That's everything that makes up. So the intermediary stuff is all the things between the endpoint to endpoint. So when you're using a network, like we might be using this network here, we might be on various PCs. So these PCs represent the endpoints. So PC1, PC2, PC3, and PC4 endpoints. If I'm sending a signal between PC1 and PC2, that signal will go into the switch and it will come down to the PC too. So this switch is an intermediary device in communications. If I'm sending up to the server here, then the signal will go up to the switch, it'll go to the multi-layer switch, it'll go to the router, go to the switch, and it'll go to the server and all the way back again. So all these devices in between are intermediary to the path that the data will take from one device, end device, to another end device. So intermediary devices are really the devices of networking, because that's what we concentrate our studies on, because that provides the network infrastructure end devices use to communicate their data over. So let's just go back and quick look at the instructions again. So we now know something about the intermediary devices. We've seen those. So it says, without entering into the internet cloud or intranet cloud, how many icons in the topology represent endpoint devices? Only one connection leading to them. So yeah, so let's have a look at endpoints then. So endpoints are the endpoints where data goes to and from. So like the home desktop here is an endpoint, laptop's an endpoint, tablet's an endpoint, inkjet printer's an endpoint. So we've got 4 there. Over here we've got a branch server, that's an endpoint. We've got laser, smartphone, this laptop, we've got phone, we've got a PC, we've got another phone, we've got a PC. They're all endpoints. Okay. And then down here we've got 4 PCs and we've got a server. So all endpoints for our networks essentially. And then it says, without counting the 2 clouds, how many icons in the topology represent intermediary devices? Multiple connections leading to them is kind of the way they're trying to suggest you identify them. But intermediary devices are things like so we've got routers. So we've got router here, switch, 2 multi-layer switches, 2 switches here, and then we've got router here, a switch, a wireless access point here. They're all intermediary devices. A router, switch, and wireless intermediary device. We've got a modem here and a wireless router here. So those are all the intermediary devices. And as it's going over the internet, there'll be millions of intermediary devices in the internet, of course. They're asking us not to count those because we couldn't. So these are all intermediary devices, all the things that aren't endpoints, essentially. So the next one. So how many end devices are not desktop computers? So end devices that are not desktop computers. Let's have a look. So we have, well, the server is not a desktop computer. It's a server. These are desktop computers. We have a smartphone. We have a laptop. could be a desktop computer, I suppose. They'll put it on the desk. It's a bit of a slightly grey question, really. These are obviously desktops. We have 2 IP phones. We have a LaserJet printer, another server, and we have a tablet device. Again, we have another desktop machine, and we could say that it's a laptop, but it could be used as a desktop, could be counted as a desktop, I suppose. And we have an inkjet. So certain things definitely aren't those. They're just trying to get you to identify endpoints and the symbols that relate to them. So the other thing is just get familiar with these symbols. So these symbols are used not only in Cisco Packet Tracer, but in other network documentation you might find, and their icons that exist. Microsoft Visio tends to be a good package for network documentation if you have to do it for your own network. So, and you'll find these sort of sets of icons available in Visio for doing this type of documentation. So inkjet printer, wireless router, modem, representation of the internet as a sort of cloud. These circles with the arrows coming in are routers. These are just plain switches. These sort of rectangles, and these ones were, like I said, with the little sun circle with all the arrows going in. There's a multi-layer switches. Servers just tend to look like boxes. End desktops tend to look like mini desktops. IP phones look like this. Wireless access points look like that. So these icons will be used not only here but in other places. So I just want you to get familiar with what you're looking at in network documentation like this, so that you recognize what devices are really. So what's next? So how many different types of media connections are used in network technology? So media technology is about, or media connections are about what the data is traveling over within a network. So all of the lines interconnecting things. So it's asking us for different types. So first of all, in this network segment here, we got loads of copper. So this is a copper straight line, straight through connections basically. So this is like an Ethernet network, copper wired. These red lines are serial connections. So these are special connections that normally simulate wide area network connections. So these are big connections going over large geographical distance, and they're interconnecting really from the ISPs and the internet providers and into your network. So these are wide area network serial connections. Up here we've got, this is media. This is actually wireless, so it's just represented in Packet Tracer and other network documentations as these little banded lines. So this just represents wireless connection. So it represents radio waves essentially being used. And I think that's it for this network design. So we've got wireless, we've got copper, straight throughs, and we've also got serial connections, wide area network connections between routers there. So step 2, explain the purpose of the devices. So in Packet Tracer, only the server PT device can act as a server. Desktop or laptop PCs cannot act as a server. Based on your studies so far, explain the client server model. Okay, yeah. So some limitations of Packet Tracer is it only has sort of fixed devices, and you can only use them in sort of fixed ways. So in reality, in sort of real life, you could take a desktop PC and you could set it up as a server. That wouldn't be a problem. And you can even take a laptop and set it up as a server. Obviously in Packet Tracer we can't do that. So we can't in terms of the simulation. There are some limitations to it. But what they're asking you about is really the client server model that hopefully you've looked at in the presentation, and just trying to get you to kind of remember what we said about that in terms of what we were seeing. So in modern networks, we know that a host can act as a client or a server, or effectively both. Software installed on a host determines the role it plays on the actual network. Servers are hosts that have software installed that enables them to provide information and services. such as email, web pages, to other hosts on the network. Clients are hosts that have software installed that enables them to request and display the information which would be obtained from the server. So a client could also be configured as a server simply by installing server software on it. So like I say, any desktop machine could become a server in that sense. Asking us to list 2 functions of intermediary devices. Well, what do these intermediary devices like switches and routers do? Well, they regenerate and retransmit data signals. That's the first thing. They maintain information about what pathways exist through the network and internetwork. They notify other devices of errors and communication failures. They direct data along alternate pathways when there is a link failure. They classify and direct messages according to quality of service priorities. They permit or deny the flow of data based on security settings. So it's really just to do with moving and managing data as it moves across the network. So intermediary devices are the major management of that data as it's moving across network connections, essentially. So they're the ones that are driving data through the network and connecting it onto endpoints across the network. So it's really important that they're there doing all that management of the connections and work along flowing the data. So it then asks us to list at least 2 criteria for choosing a network media type. So yes, so with network media, the distance the media can successfully carry a signal is really important. So different types of cable, if you're talking about network cable, or even if you're talking about radio waves or fiber, different types of any of the media have limitations in terms of physical distance that they can carry a signal. So when you're looking at different criteria for network media type, then obviously the distance that media can carry a successful signal is one of the most important factors. The environment in which the media is to be installed is also important. So, for example, coax cat like fixed cable or something like that is meant to be installed inside buildings. It is not robust enough to lay under the ground outside, for example. So if you're trying to run connections to your network across a car park or outside your building, you will need to go over to something like robust for that sort of environment, such as heavy armored coax cable. So that's a limitation of some of the cable types and media types that they require a certain level of robustness if they're going to be put under the ground and walked over and so on. So you can't, not all types of cable will do that. If it's in a wiring closet or in trunking in a building, then it can be fairly lightweight in terms of robustness, because obviously it's not going to be tramped over or buried under the ground in any shape or form. So those are 2 things that are really important. The other thing is the amount of data and the speed at which it needs to be transmitted. So different types of media will be able to transmit data at different speeds, and different amounts of data will be able to push down different cable types or across radio signals or via even fiber optics. So that's kind of the third thing. And the fourth thing, and when we think about networking, it's really important to be clear that we always have cost in mind. So the cost of the media and its installation is another sort of defining factor when we're working with networking, because it can be an expensive business, and it does dwell in the physical of laying cables or putting access points or running fiber and so on, and that can get really expensive. So it's definitely a driver to say the cost of the media and its installation will drive businesses and individuals when installing networks to make decisions on what type of cabling they want to actually use, because some cabling can be very, very expensive, and maybe that's just too prescriptive for the needs of the network that you're trying to build, and you have to kind of weigh that up. So the third step here, so compare and contrast local area networks LANs and wide area networks WAN. So what's the So it's explain the difference between a LAN and a WAN, and give some examples of each. Well, so LANs essentially provide access to end users in a small geographical area. So the definition of a local area network is that it's physically local, so it's only within a small area, really. So a home office, a school, campus, those would be sort of examples of LANs. WANs, wide area networks, they provide access to users in essentially a wide geographical area over long distances spanning maybe a few miles to thousands of miles. So that's really a big difference. A metropolitan area network and the internet are essentially examples of wide area networks. A company's intranet may also connect multiple remote sites using a wide area network as well. So wide can be very wide. It can also be slightly less, but local area networks are always just local to a geographic region. So maybe it's a business building, a campus, our network campus on the university is a local area network. So you just have to. It's not defined. There's nothing that you can really define it on apart from the geographics involved. So it says in the packet tracer network, how many wide area networks do we actually see? So let's have a look at wide area networks within our example here. So I'll just minimize this down. So wide area networks, these are the wide area networks, these interconnections. So the internet is one of the wide area networks, and this little intranet is a wide area network as well. So we've got essentially two within our diagram here. So internet and intranet is our wide area network connections that we have there. So that's what we got in this one. Next question. So how many local area networks do we see then? So let's have a look again at our diagram. Local area networks. Well, local area networks are these ones here. So they're calling one central, and they're calling the other one branch. And we also have a home office. So essentially, we have three local area networks within this this little packet tracer exercise that we're seeing here. So three local area networks is what we have, and we can see the border we put around each one. So step D or step 3D. So the internet in this packet tracer network is overly simplified and does not represent the structure and form of a real internet. Briefly describe the internet. So I suppose the internet is mostly used when we need to communicate with resources on another network, and essentially the internet is a global mesh of interconnected networks or intranetworks. So it's a network of networks is how I normally describe the internet, and that's really what it is. It's a global connections of all the local area networks and wide area networks across the planet. So if you need to communicate to any other network, either between organizations via the wide area networks or to another part of the world, then more than likely you'll be going over the internet, which is the internetwork of networks that interconnect every other network on the planet. So that's it in a kind of nutshell. So so what are some of the common ways a home user connects to the internet? It's you could have a cable connection, you could have a digital subscriber line DSL, you may still be on dial-up. I don't know if there is anyone really out there on dial-up, but for a long time, of course, people were using dial-ups and modems for years and years. So there may still be people on dial-up out there. Cellular type networks are really important now for home users, especially maybe not so much in this country, but certainly in places like Africa, a lot of African nations are investing heavily within their cellular networks, just because of geographical distances and the fact that it's too costly to lay cabling. So cellular becomes the predominant sort of primary way of connecting for home users in those sort of countries. You might also come across satellite connections as well, so your sort of sky connection. So what are some of the common methods that businesses use to connect to the internet? Well, businesses can use some of the same, so they might have digital subscriber lines as well. They're more likely to have a dedicated leased line, so that's what the university has. We lease a line from BT, and that's dedicated to us. That's our connections to our providers of our network system, so it has to be Janet. We might use HOE, maybe cabling again, or cable networks, or satellite communications as well. So again, it can vary, but very similar between home and business. It's just businesses have like dedicated lease lines or a lot of money, and you unlikely to see them in many homes. Although if people are rich enough, they can of course invest in that as well if they want that dedicated lease line. Okay, so finally it says challenge question. So now that you've had an opportunity to explore the network represented in this packet tracer activity, you may have picked up a few skills that you would like to try out, or maybe you would like to opportunity to explore this network in more detail, realizing that most of what you see and experience in packet tracer is currently beyond your skill level. Here are some challenges you might want to attempt. Do not worry if you cannot do them all. You will be a packet tracer master, user, and network designer soon enough. Add an end device to the topology and connect it to one of the LANs with a media connection. So what else does this device need to send data to other end users? So to connect to the end device, okie dokie. Let's have a look at kind of doing that. So let's go back to our network here. So end devices. So we've got some end devices here in the central office. Just zoom in a bit so we can see that. So we've already got some end devices here, PC 1, 2, 3, and 4. So we could actually end up another end device on these. These switches, by the way, these are 2960 switches. They have 24 ports on them, which means I can connect 24 different devices to each one of these. So I've only got 4 devices connected across them at the moment. So there's plenty of scope here to add another end desktop PC. So let's do that just as an example. So go to my end devices, and there's a PC icon. Just click, and it'll go to like a no entry, and then you can just click anywhere on the logical topology there, and it will add a little PC device. And then you can just drag it and move it into your topology here, and we can move these ones around a bit. The way we arrange them is important. We tried to arrange them as a little sort of hierarchy, really. So we try to arrange them top down. So we have our sort of core layer of networking at the top, going sort of backbone stuff, and then we have a distribution layer, and then we have an access layer, and then we have our end devices at the bottom. So I'm going to squeeze this machine in here. We've got PC1, PC2, PC3, and PC4. I'm just going to rename this machine just by clicking there. This is like sticking a label on it, by the way. This isn't part of its configuration. It's just to stick a label on it so we know when we're looking at the diagram what that's going to be called. So we call that PC5, and I'll put it over this side actually. Let's add it to this switch here. So put it down there. So to connect it up to the switch, we need to cable it, and we need some media. So we use our connections, and a PC to a switch would be using a straight through copper cable. So we're going to just use the copper cable there. Click on that, click on the PC. These are the various ports on the PC. Fast Ethernet is the one for an Ethernet connection, of course. We've got some USB ports, and this RS232 is a serial connection, like a COM port that we use for connecting to our console cable, but we don't need to get into that at the moment. Let's just use the Fast Ethernet, and when we do that, we get a line coming out, and that's our cable, and we can then click on the device we want to connect it to. So in this case, a little switch here, 2960 switch, and if you hover over a device, it actually tells you something about the device. If I keep it still on the mouse, and this is telling me what's connected on it, so I can sort of show me what's on the what's plugged in at the moment. So I can see that at the top there it says fast Ethernet 0/3 and 04. They're the ports on it. It says they are up and operational. So they're available to me, as is fast Ethernet 23 and the gigabit Ethernet connection as well. And let's just click on S2. These are the ports I can plug into. I'm just going to plug into fast Ethernet 01 like that. And my connections go green. This just indicates I have a successful connection to the device. If I get orange or red, there's something not working in that connection, as you might imagine. This just says I have a working connection here. It doesn't say I can actually communicate at this point. Just says the connection's operational, really. So it's not an indicator of like it's working. And in fact, the question now is, or the question posed was actually add an end device to the topology and connect it to one of the LANs, which we've just done. But what else does this device need to send data to the other users? So what this device lacks at the moment is it does not have any IP addressing. So any device that you connect to the network has to have an IP address, has to have some addressing on the network so that it can communicate with other devices. And sometimes this will get it automatically using something called DHCP, Dynamic Host Configuration Protocol. And if I click on the little desktop there, end device, I get some tabs come up. Desktop aims to simulate a Windows type desktop environment, really. These are sort of applications that would run on that we can use. And one of those is the IP configuration. So if I click on IP configuration, this allows me to configure the interface for my IP configuration here. So at the moment it's set for static manual IP version 4 and static manual IP version 6 configurations, and there's no details actually on here effectively. So let's just see what happens if I click DHCP on the IP version 4 configuration. So if there's a DHCP server on this network, then it will give me an address, and sure enough, it has done. I've been given the address of 10.3.0.5 and a subnet mask of 255.255.255.0 and a gateway address of 10.3.0.1 and even a DNS server is in there, 10.10.10.2. So I've been given some information with DHCP. I could move back to static and I could put my own networking address details in there if I wanted to, and but as it's got a DHCP server running, we will utilize that. Obviously, through the course of the module, we'll learn how to do static addresses and configure our networks with the addresses. But essentially, this device needs networking IP addresses configured to the network segments in the LAN segments here. So hopefully this is the right address information. If it is, then it can connect, but it does need that addressing in order to function. So it's got it there. What else do they want to know? So what else do we need to send data to other users? Well, that's essentially it. Can you provide information? Is there a way to verify that you correctly connected to the device? Oh yeah, so the verification process for can this device actually work, is to be able to what we call ping other devices. So ping is a little like test pool device application that we can use, which just simply sends one little message to another device in the same network. We use it to send messages. If we get a reply back, we call it echo response, echo reply. If we get an echo reply back from a device, then we know that we are connected successfully and we can reach that device. So let's try getting to PC4 here. So in order to use ping, we need to know the IP address of the device that we want to reach. So this device, IP address 10.3.0.3. So 10.3.0.3. Let's go back and have a look at our configuration again, just briefly. It's also on the 10.3.0. So 10.3.0 is actually a network. They're both on the same network. One's 3 and one's 5. So let's see. And we can use the command prompt on PC5 here to actually send a little ping. And to use ping, we just type the word ping, space, and then we type our network address. So 10 dot. I've immediately forgotten the network address, but it was the same as our own. I'm just going to do IP config, which is a command to bring up the configuration of this particular device. I'll just make that a bit bigger so we can see. 10.3.0.5. Right, so we want to ping the other machine, which is free, on the same network. So 10.3.0.3. That was the other PC that we wanted to see if we can connect to. So ping. Oh, there we go. We're getting some replies back from that device. So these, with ping, it just sends 4 messages, which we call ICMP, so Internet Control Message Protocols. And it's a workhorse protocol used to send all sorts of testing and other sort of workhorse data across the network. So ping sends 4 of those. They're called echo responses, and they go out to the other PC in this case, and who responds back with a we go out with echo request, and it responds back with an echo reply. And when it comes back, this little reply is recorded here, and this is the time it took in order to go out and back. And TTL stands for time to live, which we can get into at another point, but that's indication these are Windows machines that are communicating here. So it gives me the time that it took to get backwards and forwards between being sent and being received. So this is a major tool for testing whether our device actually can communicate. The other thing we should do here is the default gateway. That address there, 10.3.0.1, that's the way out of the network. So the gateway is the gateway out of the network for this particular machine. Obviously, to communicate to other devices across other networks, it's going to need to be able to go out and leave its network to do that. So we should also ping that. So we should ping another device inside the network, and then we should also ping out to get out to the network, the gateway. So let's do that one as well. Quick tip: up arrows in your on your keyboard, they bring back the previous commands that you have typed in. So you can see I can scroll backwards and forwards through those using my up and down arrow keys on my keyboard. Just saves a bit of typing because I just want to go back to 10.3.0.1, which is the gateway for this particular machine. So I just need to ping back that and enter on that. That's ping. So this is pinging the gateway out of my network, which is also giving me responses. So I know that I can get to the gateway, which suggests that I can get communications out onto other networks. So that's really good. So testing those two, testing a device inside the same network and testing a device for the gateway is also really important. I don't know about the configuration of this network too much, but we'll just minimize that down. Let's have a look at the network. I could now try also pinging maybe a device on a different network. So for example, PC2 over here is on, if I hover over it, it tells me that this address of this PC is its IP address is 10.2.0.5. That's on a different network segment within this local area network to the PC5 that I've just set up. So I want to go and ping that. So that would actually involve going out of the network via the gateway out to another network. So if we can get a connection to that one. So again, I'm just using map arrow just for convenience. Oh, in here. So let's just change it. So it's not 10.3, it's 10.2. That's a different network. So and it was 10.0.5. Let's see if we can get a communication back to that PC or not. So, we got okay, there we go. We're getting some replies. Then we got a timeout initially. This is interesting, just to point that out. You sometimes get timeouts. Sometimes on the first ping. The reason being is it had to learn the route. So there was it didn't actually make it back because it had to learn the route first. That's a simulation thing, but then the other packets, because it learned the routes, are able to find their way through the network. Notice here also, just so we're looking at these results, The time to live on these first ones we sent when we were sending to a device inside our own network, 128. That's essentially there's no journey, there's no hops, as we say, between no networks traveled on that one. But on this one, 126, we've gone down to. That's because it's gone over one network in order to go out and another network to come back. So the time to live has been reduced because it's gone through 2 hops essentially, from 128 to 126. So that little figure there tells me kind of rough calculation of how far this packet has been in its travels. It's been across two network segments, at least in coming back to me. So that's an indicator of where it's been. So we've got communication. This is good. So that's what we'd use. Ping is a major tool for testing our network connection. So with that tool, I've just been able to test the network I'm in, the gateway, and getting out to other machines on other networks nearby. And I can even go local area networks, maybe to another local area network connection. But that's probably enough, just for now. Okay. So we can verify a connection directly. So the next thing is add a new intermediary device to one of the networks, connect it to one of the local area networks or wide area networks with a media connection. What else does this device need to serve as an intermediary to other devices within the network? Okay, so let's have a look where we might put in another intermediary device. Now I was struck up here. So in a home office, which you might have at home. So at home you might have a single wireless router like this one, and that's fine when you've only got a few devices on it. But when you get more than just a few devices on that, it might be useful to have a switch. So a dedicated managed switch allows you to kind of manage your network infrastructure a little bit more robustly and a bit more managed ways. So wireless routers like this tend to have switches within them. This is a bit multi-layer, but you might have a dedicated switch device as well. So as they're asking us to add a device, let's do that. So I'm going to add under network devices. I'm going to go to switches, and I'm going to put a 2960 switch in here, and I'm going to connect that switch up with Ethernet connection, straight through connection, fast Ethernet to Ethernet 3 is the first available port here. There we go, put a switch on there. And in the Cisco world, we tend to just number these switches in the packet tracers anyway. Let's just call this S1 for this. Oh, there's already another S1 somewhere in this network design. So call it home switch 1. So HS. There we go. Right, okay. So that's connected to the network. Notice we're going orange at the moment, so that's not connected there. But now we've got in green, so we have a connection between these two devices. So switches tend to connect into networks straight away because they're just switches. They don't need any IP or anything. So to make it available to other devices, well, it's kind of working a bit out of the box with a switch if you add a switch in, but you need to configure it in some ways. So to make it useful, we'd want to put some configuration settings on the switch. We'd also want to think about how we're going to integrate it into our wireless router there. So yeah, so there's a few things to think about in configuration and setup and so on. You wouldn't just drop it on. You'd probably do some work on it in terms of configuring it. But that's stuff we're going to come on to anyway. So pretty sure quite what they're getting at the moment. We can connect it in and then plug it in. So that's an intermediate device. So yeah, so that's okay. Open a new instance packet tracer, create a new network and at least 2 local area networks connected by a wide area network. Oh, that's quite challenging for week 1, part 1. Connect all the devices, investigate the original packet tracer activity to see what else you might need to do to make your new network functional. Yeah, so they're really pushing you on this one to try and they're basically just saying, go ahead and do some networking, and then you've only spent week 1 on it. But just to do that, we could actually set up a blank packet tracer maybe, and I'll just run you through doing exactly that because they've asked you to do that. I'll do it, and just basically, and then you can kind of watch and see an example. So bear with me a second. I'll just get a blank packet tracer on the go, and we'll be right there. So let's go to our blank packet tracer. Okay, so as if by magic, here we have a blank packet tracer, and so the object was to build a little network, I guess. Very simple. So let's get some network devices on the go. So what do we need? Some intermediary devices. So like I say, let's have a router. So 1941 is our core router there. And it said about having 2 local area networks connected together with a serial connection between them, so a wide area network. So we can do that. Let's have two 1941 routers. And I'm just going to number them. This is just like I say, sticking a sticker on your routers on the front of them, just so you identify. It's not anything to do with configuration. Oh, if you don't click quite on the text, it opens up the device. So you do have to be careful with that. Let's call this one router 2. So there we go, 2 routers. Let's zoom in a bit. And move them as a group. So let's put them at the top there. So each router, we're going to give a switch. So in a sort of corporate enterprise network, you will have switches as your distribution layer connecting to routers. So we'll have 2 switches. And again, just for ease, we'll call them S1 and S2. There we go. And we'll have some endpoints as well. We'll just have one endpoint either end. So end devices, PC, and we'll have another PC over here. Just because I'm a bit lazy, I'll to renumber it and delete that one, and then create another one, and it'll call the next one PC2. It just does them in order. So we'll have PC1 over here and PC2 over here. And to distinguish our LANs, we should draw some little rectangles. So we'll draw a no-fill rectangle, and fine. So I just want a rectangle over here for one LAN, and a rectangle over here for the other LAN. Okay, just to differentiate the two. That and give a little bit of space between them. Distinguish each one, and let's put a little note on them as well. Where's my? Ah, there it is. Right. Okay. So we'll call this one. This one will be LAN 1, and over here we'll have LAN 2. Oh. Yeah, so we know what they are. LAN 1, LAN 2. Not the most creative of names. Router 1 to router 2. Now these routers, if I click on those, in order to get a wide area network configuration going as they suggest, we're actually going to need to install a little bit of hardware. And what's nice about the packet tracer is we can actually look at the back physical of these boxes. So maximize that one up, so we can see the physical what the box looks like. We haven't got like an on or off switch here. It tries to simulate everything. So if I want to install some new hardware in this device, I have to turn it off first. So let's just turn it off with a switch. There goes that little light, so that's down. And I just need to install a card in the back here to allow for wide area network connection. So I'm going to install this this device here. So you click on these options here. These are cards that will fit this device. and here it describes what it is. So this is a Cisco 2-port serial high-speed wide area network interface card, and I'm going to install it in this slot. So I just click and drag it up to the slot, and it bonks it in like I've screwed it in and connected it up to the device. And for completeness, I should put a cover over any empty slots so dust doesn't get in. So we try to do it like a real world exercise. And we'll turn that device back on again. That gives me a couple of wide area network connections that I can use on this device. And if I just close that one, and that's router 1. On router 2, I would also want to do the same so that I can interconnect those two devices. So again, Cisco 2-port serial, high-speed serial. So let's put that in that one. Oh, see, if I haven't powered it off like it would in reality, it nags me. So I have to turn it off, which is why it's good to zoom in. There we go. And now we can plug that into that one. And again, just for completeness, I shall put a little cover over the blank socket and turn it back on. If you don't turn it back on, it's not going to work. Good. So now I need a connection between these as a wireless network. So the wide area network is the serial connections. Like I said, 2 ends, clocked end, DTE, and DCE, and a DTE end connection, digital terminal, digital clock, digital terminal equipment, DTE, and digital clock equipment. So yeah, so we use the clock from R1. Serial 00, that's one of the serial wide area network ports. I'll just put the device in, we'll drag that across. Don't need to drag, just move your mouse. And then click again, serial 00. That's our wide area network connection established between R1 and R2. Not configured, but they are there. And then let's have our PCs connected on fast Ethernet. The first available fast Ethernet port on S1, and we'll do the same over here between PC2 fast Ethernet, the first available fast Ethernet port on the switch, and then from router to switch, also straight through copper cable, gigabit Ethernet 01 to routers gigabit Ethernet 00. Or in fact, let's do gigabit. Oh, it's a bit hard to kind of disconnect that. If you get trouble, I'm just going to delete that cable actually. Drag that. So I'm going to do gigabit Ethernet 01 to gigabit Ethernet 01, just so I know it's the same on each end. It just makes it a bit easier to keep track of what's plugged in. So gigabit Ethernet 01 to gigabit Ethernet 01. There we go. Yeah, there we go. So that's a little topology. 2 LANs, 2 PCs, 2 end devices, 4 intermediary devices, some Ethernet cabling going on, and a wide area network cabling. So we've done, in terms of topology, we've set up what they wanted us to sort of challenge ourselves with. We'd have to come up with some addressing scheme for these networks. So okay, let's go. Let's go that. We could go even. I could be here all night building a network here, but let's just see if we can get some connections going then as we've gone this far. So let's do 192.168.1.0/24. Obviously, we're going to come to how to do network addressing like this. But just to tell you now, 192 addresses you'll see a bit of because they are what we call private network address ranges. You can't use those over the internet, but inside business networks, you might address your machines in this way. So it's going to become fairly familiar to you as an address type. Okay, so I've done this network over here is going to be 192.168.2. And this one's going to be 192.168.1. Notice in my use of the numbering there, I'm kind of cluing myself into LAN 1 and LAN 2. It's a bit easier for me to remember the addresses I need. So let's give this PC desktop configuration. I'm just going to use static IP version 4 addressing. So let's go 192.168.1.1. Subnet mask, it'll put it in automatically actually because this is a class C addressing. Again, you're going to come on to these terms later on, but this is 255.255/0 or .0. That's what the /24 means. It refers to the number of 1 bits within this address. So again, we'll come down to that, don't worry. But it's a shorthand way of writing the same thing. So rather than writing out 255.255.255.0, which I have to do for my subnet mask to put it in, but as a quick shorthand for that, as a prefix, I can just do it /24. So my default gateway, which isn't set up on the router at all yet, but I'm going to. So I'm going to call that 192.168.254. Oops, I missed one. So 1.254. 254 is the last available address within that network address block. So again, it just helps me to remember which one it is. Don't need a DNS server, that's kind of optional if we're not using DNS at the moment, so that's fine, I'll leave that bit out, we can't go too far. So addressing for the PC is done. Let's do PC2 over here, and we'll keep to the same essential format on that one. So 192.168.2.1. Subnet mask, again, it's RC, so it'll come up with the same subnet mask. And the default gateway 192.168.2.254. Okay. Right. Okay. So let's now configure our router. Now, to simulate a router configuration like in the real world, what you should really do is get the end devices, get a laptop like that one, and we should just configure it. In fact, I don't know, do I need to configure it? Let me just test this out a second. Console cable. No, I don't need it. It's already got the port on it. So a console cable, what we normally do on a laptop is plug a console cable into an RS-232, sometimes USB, depending on what cabling we're using. And we'll assume RS-23 here too, which is a serial cable. But this is for console cable, so we take a connection from there and using a special blue wire, and it's color-coded blue as a console cable in Cisco world. And we click on the router, and we can plug that into this special port called the console port. And that means that we can then use our laptop and a special piece of, if I go to its simulated desktop here, we have this special bit of software called terminal connection. And that's in putty. In real life, you'd put this bit of putty software on it. And we run a terminal connection to it. Just use the default settings here. Okay. And I'm into the device. It's command line. I don't want to do a configuration. Thank you very much. So no. And this is it. So it's command line interface in order to configure this device over the network or over this console cable, and that's how we'll do it. So this router is R1 here. So I'm clicked on that via the console cable, via the laptop, like I would in reality. You can also, because it's packet tracer, you can just click on R1 and go into CLI, which stands for command line, and you can do the command line configuration settings here. And mostly you'll do that because it's just saves a bit of time. But I tried to give a sort of more realistic sense of what you're doing by hooking up a laptop like this with a console cable, because that is what you would do in real life. So you'll need your console, you'll need your laptop, you'll need a console cable, and you'll plug it in, and then you'll use a bit of terminal software, which is what we're trying to simulate here, to access that device and use your screen on your laptop and your controls to actually control it. So yeah, this is more realistic, I think. So let's do some commands. So again, you're not going to be doing this or familiar with this stuff at all straight away. It takes time to build this knowledge up, but you can watch me do it. So enable gets me into the user exec mode, as we say, from user mode, which gives me a bit more rights to work with it. configure terminal. Allows me to actually go into the global configurations. You notice the command line, you know where you are based on just this little bit here. But this hash indicated me in the user exec mode. This little chevron indicated I was in user mode. And this config in brackets and the hash indicates I'm in global configuration mode. So I'm in various different sort of sections of the device, but that's my indicator. My prompt is the indicator. This bit is just the name of the device. I'll rename that in a minute. They all come out as router, but we'll rename that so we know. That'll be the first command we do. In fact, I'll do that right now. So the first command we learn is host name, followed by whatever name you want. Uppercase characters are always used in Cisco. No spaces, but we can use numbers and letters. So R1 is what we put our sticky label on the front for, and I'll just change that. So when I remote access into this via terminal, I know which device I'm on because all you see is the command prompt. So as we're seeing here, so if you don't change that name of the device straight away, something recognizable, then you may not know. If they're all called router, how would I know where I am? So what do I need? So I need on the interface where I've connected up my PC or my switch to it, I'm going to need to configure that interface, and it was gigabit Ethernet 0/1. It's going to need an IP address, and we've already kind of determined it because it will be the gateway router for PC1. So it'd be 192.168.1.254. And the subnet mask 255.255.255.0, which is /24 subnet. By default, router interfaces are actually, one thing to note is they're actually shut down. So they're not on automatically when you plug them in. So in order to turn them on, you have to do this command, no shutdown. Seems weird because you think, why am I doing a command that says shutdown in it when I want to turn the interface on? They are effectively shut down, and you are doing no shutdown, which means you are taking the shutdown off, and they'll come up. I know, it's Cisco world. It's an odd world. But no shutdown is the command to actually remove the shutdown command. Anything you want to remove command-wise, no is normally the way to do it. So you remove, if I wanted to get rid of the address, for example, I say no IP address, and it would take any addressing off. So no shutdown just removes the shutdown function and brings the device back to life. And in fact, this message is now telling me that that is now back up and running. So state change to up, line protocol up. This device is now activated and operational with that IP address. Let's just exit. Exit, by the way, takes you back a mode. So I've dropped down from global configuration, or back from the interface back to global configuration. If I exit again, I will go to user configuration, or exec mode. And if I exit again, I'll go to user, which is where I came in. And if I exit again, I go all the way back to, oh, actually I won't with this because I'm not on remote access, but I'll just back in the terminal. I'll just close the terminal. Okay, so that's that device connected for this connection here to the local area network. Let's pull my cable out and pull it over and put it onto R2 console, and again come back in terminal, connect to that device, do resort settings there, and I'm now on the other switch, other router. So no to the, always do no to the initial configuration dialog, by the way. That is like an automated process you can step through. You're going to learn how to do this properly, so you don't need any auto configurations. So just say no to those, and it will get you to a command prompt. So again, enable configure terminal. Notice I'm filling in. You notice I'm writing a few bits here, so I'm doing like a T. I'm actually pressing the tab key on my keyboard, and tab is for like autocomplete these terms. So if there's a unique command that kind of matches just that letter or combination of a couple of letters, then it will match to it if I use the tab key, and it just saves a bit of typing. Plus it means I get spelling things right. Interface, gigabit Ethernet 0/1. Let's give this one an IP address. So this is going to be the default gateway for the other network, and so again we've already kind of determined it by doing 254 in the configuration for the gateway of the E2. So 255 and 0. There we go. So it's an IP address, and let's turn it on. No shutdown. There we go. So we've got IP addresses on our routers for this, and you can see that one coming available there. This, by the way, if it starts up, this is time. It works in real time, so we're in real time mode here. If I want to speed up time, I can use the little arrows here, and it just speeds up. The one next to it, by the way, be careful. That one actually power cycles the devices and turns everything off and on again. Which with configuration like we've just done, we haven't saved those configurations anywhere. So if I was to power cycle now, I'd lose all the little bits and pieces that I've done with the IP addresses and so on. Will get wiped out. So I have to save those devices first, which I'll show you in a minute. But just don't power cycle accidentally. So finally, we just need an address to connect between these two, this serial connection as well. So let's give it an address then. So again, we'll just invent something. So this is the wide area network. So WAN 1, and we'll call this. Let's give it an address of 10.0.0. Let's go all the way 0/30. So a different subnet mask for this one. Okay. So this is our wide area network in the middle here. So what we will do is let's console back to R1, and we'll give R1 an address for its serial connection. So again, I've gone all the way back, haven't I? So enable, forget terminal, and interface serial 0/0/0, IP address 10.0.0.1 255.255.255. Oh, 25. Oh, come on. 255.254 and 254. Yes, 254. So this is a kind of topmost address. No, not 254. 252, sorry, that was wrong. So 255.255.255.252 is a /30 bit address. It's the topmost address you can do for a subnet mask. It only gives me 2 connections basically, 1 and 2, and I only need 2 over a wide area network. 1 at either end, so 10.0.0.1 at this end, and I'll do 10.0.0.2 at the other end. And when we talk about IP addresses later in the module, you'll understand why I've done that. So again, no shut to bring this one. One of these ends need to be clocked. So let's. This is the clock end, I think. When I did my connections, this is the PCE end. Yeah. Okay. So clock. Right. By the way, this little question mark allows me to remind myself of the commands that kind of follow if I forget. And these are all the different speeds I do. Normally I would do 128,000 bits per second. You could go down to like a nice 48,000 bit per second. So 128 is the 128,000. So 128,000 at this for a wide area network. serial connection anyway. Let's set the clock rate, and now we can do no shutdown. There we go. Cool. Good. About that one, and let's go over to here. Notice these haven't gone green yet because we haven't got this end configured. So again, we'll terminal into that one. Okay. So we're already in the configuration for an interface, not the right interface though. So let's exit from that one and go to interface. Ooh, up a little bit. So interface serial 0/0/0, and again put the IP address on this end. So 10.0.0.2 255.255.255.252. No clock end on this end. It's only on one end you set the clock rate. So that was the DCE end at the other end. And just do no shutdown on this one. Brought it up. And in a few seconds, hopefully we'll get a little message about the line protocol as well. There we go, that's the line protocol. That means I'm plugged in and connected both ends. So let's just see now. So now we've got green here. So these are all connected and configured. We've got IP addressing here on all the endpoints. We're getting to the point where we've kind of got a working, viable network. Nothing fancy in terms of configurations or settings, but we have got working IP addresses and working network. The only thing here is these two devices. Yeah, we are directly connected, but this router 1, doesn't know anything about this LAN over here. It doesn't know anything about this 192.168.2 network. Similarly, R2 doesn't know anything about this 192.168.1 network. So in order to be able to pass messages between these two networks, they need to be informed about each other. So in order to work out where to send message on, they need to know what's at the other end. So we need to tell them. There's two ways we can do it. We can either tell them, or we can use dynamic routing protocols, which actually go off and find out that information for themselves. But just to, again, try and keep this simple, I'm just going to use a static, what we call a static route. So a static route is where we actually tell it manually where a network is. So let's go back to R2 and let's go back on our terminal. And again, I'm in the interface here. I don't want to be in the interface for this. I want to be in global configuration. So let's set up an IP route. So IP route is for a static route, and then destination that I'm trying to tell it about is going to be the 192.168.1 network, and I need a prefix mask for that one. So that's on 255.255. Whoops. 255.255.0. So that's the network it doesn't know anything about, and I'm just about to tell it. And then it says, well, how do you actually get to that network then? And I can tell it to use serial 0/0/0. And yeah, because I'm using a wide area network. Okay, well, I won't tell it that. I will tell it I will tell it to use 10.0.0.1, because that it knows about that network because it's directly connected to it. So let's use that. So to get to 192.168.10.0, 192.168.1.0, then you need to go out via 10.0.0.1. So I've just given it a route, basically. I've told it, if you want to get over to this network, use this connection here, and that will take you there, which is the connection to R1. So it will know to send the messages that way. And on this side, I'll need to do the same. Give this one a route to the other side, because that will need to come back. So how does it get back? So it will need to know from that network also how to get to the other one. So let's give that a little root. Again, I'm on the interface configuration, so let's exit that and do IP root. So 192.168.2.0, 255.255.255.0, and to get to that one, you go down to 10.0.0.2. Yay. Okay, so it's got a root. So let's see if we can actually communicate now. So PC1, and we are going to ping its default gateway. So this is my ping command again. So ping 192.168.1.254 is the gateway. There we go, and we get replies back. Good. By the way, the time to live, I mentioned that before. It's just interesting. 255 indicates a Cisco device at the other end. So different manufacturers will have different time to lives. Is how I can tell that. So 128, it's a Windows machine. 64, I think, is a Linux machine. 255 is a Cisco device. But they all will have their own. You know, you can tell what they are. So that's pinging the gateway. Let's try the other device. Yeah, let's just go for it. Go for it. I'd normally test the other side of the network, PC2 on, but let's go for it. So 192.168.2.1 is the other machine. Let's see if we actually get across with our little routes there. Yeah, we expect a timeout on the first one because it has to learn the route. Even though I put it in, it still needs to find its way. And we're getting a connection, so I'm able to communicate backwards and forwards. No, it's 126. That's Windows, so it's gone 2 over hops on journey from 128 down to it decreases. This time to live decreases. The idea is to stop traffic proliferating in networks forever. So it just demarks as it commences. It goes over routes. So 126. I know it's come 2 hops. Good. Okay. Cool. Could test the other end as well, but if it goes one way, it's definitely going to go the other. So I'll go on just to make sure it's working that way. So 192.168.1.1 on the other side. Yay, a reply. So that's good, as we expected. So I guess this is kind of what we aim to do in this network, in this module, is make this type of network. So if you can build this and know what you're doing, then we've kind of done our it's working. the skills are there, and obviously there's a lot more configuration that we can do, and security features and all sorts of stuff that we can put onto this. But that's basically the network in a nutshell. That little build there. So hopefully you've got a lot out of this. It's been quite a long video, but useful as a first sort of exercise just to really get you going with Packet Tracer, and have an example of building in Packet Tracer from scratch, which I think is really useful, and obviously doing the little exploration of the network that the exercise gave you at the start. So hopefully that's been enjoyable, and it'll be a useful sort of reference point going forward. Again, if you need to contact me or have any questions or anything, you can email me on that. But onwards and upwards, as they say. So thank you for your time.